All right, let's just jump right in. For this explainer, I want you to put on your detective hat because we're going to venture into the hidden world of our digital lives to figure out what really happens when things on the internet just break. I mean, who hasn't screamed this at their screen, right? You click a link, you try to load a page, and you get nothing. It feels completely random. It's so frustrating. But you know what? It's not magic. There's always a reason. And here's the secret. Your computer, your phone, they're constantly talking. There's this invisible storm of tiny messages flying back and forth every single second. And if we can learn to listen in on that conversation, we can solve pretty much any digital mystery out there.
Okay, so how exactly do we eavesdrop on that secret conversation? Well, that's where our Digital Detectives Toolkit comes into play.
The main trick up our sleeve is something called packet analysis. Just think of it like this. Everything you do online, from loading a web page to sending an email, gets broken down into these little digital messages called packets. Packet analysis is all about intercepting those packets and actually reading them. And our main tool, our magnifying glass for this job, is an amazing free program called Wireshark. It lets us see every single one of those conversations our computer is having.
All right, let's crack open our first case file. This is a classic one, the website that just refuses to load properly.
So meet our user. We'll call him Packet Pete. Pete's a huge basketball fan. Every single morning, he checks ESPN for the scores. But today, the site's a total mess. It's slow, images are missing, stuff isn't loading. A super common problem, right? So what's our first clue? Our detective fires up Wireshark and sees Pete's computer sending out 7 messages. These are called HTTP requests, asking for website content. Things like, hey, send me this picture, or give me that article. Seems pretty straightforward so far.
But then our detective looks at how many separate conversations are happening, and there are 8 of them. Now hold on a second. This is where it gets weird. This is our first big clue, this mismatch. You see where I'm going with this, right? 7 requests for stuff should mean 7 conversations. But we have 8. That 8th conversation, it's like a ghost. It's happening, but it's not asking for any content. This is the thread we need to pull on. And this chart just lays it all out perfectly. On the left, you've got a normal, healthy network greeting. It's a quick 3-step handshake. It's like, hello, hi, I'm here. Awesome, let's talk. But look at our mystery connection on the right. Oh boy. Pete's computer says, hello, and gets total silence. Crickets. It tries again, a little louder. Hello, are you there? And still nothing. It was trying to talk to a server that just wasn't picking up the phone. So the diagnosis? Pete's computer had an old address for one of ESPN's servers saved in its memory. It's called a DNS cache. It's basically a little address book your computer keeps to be faster. But it was a stale address. It didn't even bother to ask for new directions. It just dialed the old wrong number. And of course, that server had moved on. So his browser just sat there waiting and waiting for a response that was never going to come. And that's what was breaking the page. Case closed.
Okay, case number 1 is in the books. Let's move to the next file. This time, we're dealing with devices that just go completely silent. So Pete's also got this home weather station that sends data up to the internet. One day, he notices it hasn't reported anything for over 9 hours. The device itself looks fine, all the lights are green. Our detective realized the clue wasn't in the message the station was sending out, but in the server's very quiet reply.
And boom, there it is, the smoking gun. Buried deep inside one of those tiny packets, the server sent back this crystal clear message. Turns out, the weather station's password had somehow been completely wiped out. The server was just rejecting its connection every single time. A super simple fix, but one Pete never would have figured out without being able to read the packets. Now that one was pretty easy once we found the message, right? But what happens when a device goes silent without leaving any clues at all? In this next little case, a big printer in a sales department would just stop, right in the middle of a big print job. No error messages on the screen, nothing. It just gave up. So again, let's look at the conversation. On the left, normal printing is this polite back and forth. The workstation sends some data, the printer says, got it. Easy. But look at the failing printer on the right. The workstation sends data and gets silence. It waits a bit and then asks, did you get that? Still silence. Finally, it gets desperate and just starts resending the same data over and over, basically shouting into the void. You see, these repeated shouts, they have a name.
TCP retransmissions, and they are definitive proof that the sender is doing its job, but the receiver, in this case the printer, has gone completely deaf. This told the analyst, hey, the network is totally fine. The problem is inside the printer itself. And what was the culprit? Turned out to be faulty memory in the printer. For our final case, you know that classic horror movie trope? The call is coming from inside the house? Well, sometimes the problem isn't out there on the internet. It's right there on the user's own computer. The packet capture on this one showed just a bizarre sequence of events. The user tries to go to google.com, totally normal. But then, look at step 2. The computer doesn't even bother asking the internet for directions. Instead, it turns to a random coworker's PC on the same office network and asks it for the Google website. Naturally, the coworker's PC has no idea what's happening and just says, "I'm not a website," and slams the door shut. So the diagnosis was a bad entry in the computer's local address book. It's a file called the hosts file. Someone, or maybe some malware, had basically scribbled a fake address for Google in it, telling the computer that google.com is your coworker down the hall. And because the computer trusts its own local address book first, it never even bothered to look online. Okay, so we've cracked a few cases, we've seen some weird stuff. What's the big takeaway here? What have we really learned from our time as digital detectives?
Well, first, and this is the big one, the packets are the ultimate source of truth. They are an objective, unbiased recording of exactly what was said, who said it, and when. They just don't lie. Second, the problem is often closer than you think. Before you go blaming your internet provider, your own device is a prime suspect. And finally, you have to remember that every single click you make kicks off this complex story of requests and replies. And learning to read that story, well, it's basically a superpower.
And honestly, this quote from the analyst who worked these cases just sums it all up perfectly. In a world where everyone's pointing fingers, the packets give you the cold, hard evidence. They really don't lie. You know, right now, as you're listening to this, your computer, your phone, maybe your smart speaker, they're all having thousands of these tiny conversations every minute. They're all telling a story. And now you know that if you just learn how to listen, you can hear the secrets they're telling.